this on Old Smoky. Write the word similar. And we are looking at today specifically similar polygons and what they do for us, what they are, how to work with them. Okay, first of all, if polygons are similar, I guess let's draw a similar one. What should we draw? No, let's do rectangles. Whoever said rectangles, that was a good idea. Okay, let's say I start with this rectangle. You help me out here. Would you say that looks about similar? Say yes, because I don't think I can pick the thing up.
Yes.
Okay. Here are some things that you know about similar. First of all, similar shapes are not exactly the same. They have what we call proportional sides. Look at that, proportional sides. Okay, that simply means this. If this side of my rectangle, let's say we know these are similar. If I know that this side of this rectangle is 4 inches, and I know that this side of its proportional rectangle is 8 inches, if this is 6 inches, I can figure out this side because I know they are proportional. Laney Kabar, are you with me? Now, how would I figure that out? Well, there's a couple different ways. We can do it with a ratio or proportion, or one way you could just sit here and look at this and go, well, 4 times what gives me 8? What is my scale factor, I call it, Isabel? Times 2. That means every shape, every side on the small one, you would just need to multiply by 2 to get its what we call corresponding side on the bigger one. So 6 times 2 would give you that side on that one right there. And we need to write that down. The word corresponding. Corresponding sides are what we call proportional. What does that word corresponding mean? Well, it's hard to describe in any easy terms, but I would say you could use the word the sides that match up. In other words, if you're looking at the small rectangle, the small side on the small rectangle corresponds to the small side on the big rectangle. Same thing, the longer side on the small rectangle corresponds to the longer side on the bigger rectangle. And you'll be able to do that, and that'll help you find out some shapes. Something else you'll have to understand is this. This is a great one right here. If you have similar polygons, if similar, comma, corresponding angles are equal. Corresponding angles are equal. And that's not such a big thing with a rectangle because what are the angles on all rectangles? 90 degrees. So really with that it doesn't matter. But if I draw some corresponding triangles through the magic of the corresponding triangle drawer here, let's say I have this triangle and I have, would you say that's kind of similar? Wait, first of all, would that be similar? No, it has to be the same shape there. Now here is the deal. If I know that these are similar, let's say we got A, B, C, D, E, and F. Angle A would corresponds to, angle A corresponds to what angle on the small triangle? Right, Harrington? Angle D. And because they're similar, if the book would tell me that angle A is, what does that look like? Maybe 30 degrees? If angle A is 30 degrees, then angle D also has to be 30 degrees. This looks like an isosceles triangle, I'm sure it probably is. And you could tell me, how many degrees do you think C and D are? If this indeed is an isosceles triangle, these two angles are going to be equal. Triangles have to add up to how many degrees? 180. 30 of them are wasted right there, so I have 150 degrees to make up with these two, and they're both equal, so 150 cut in half is 75. 75. Guess what these two angles are? 75 and 75. So if you have similar shapes, the two things you have to know are that their corresponding angles are equal and their sides are proportional. Let's throw another thing at you. If it's proportional, how about this? Let's say if this was 9 and this was 3, what if this was 20? How long would this be? Question mark. Now I can tell by the questioning look on your faces here. Here is how you can figure this out, children, because it doesn't work out evenly and some people are looking like, I don't know. You can make a ratio slash box here. Make this one the small triangle. Make this one the big triangle. Make this one, whatever side you're comparing, small side. Make this long side. Fill in the blanks and see what you get. Looking at the small triangle, do I know how big the small side is? Sure I do. It's 3. Do I know how long the big side is on the small triangle? I don't. That's my question mark. On the big triangle, do I know the small side? It's 9. Do I know the big side on the big triangle? It's 20. And guess what you have here? Equal fractions, equal ratios. You have 3 over some number you don't know equals 9 over 20. How am I going to solve that, Elijah Fisher? Three by what? Then I get what? 3 times 20 is 60, and what do I do with that then? So I make it equal to 9 times n. And then now what do I do? By 9. And people, because you're in 7th grade now, you can leave it as an improper fraction. It's not going to work out, but you do need to reduce it. What is 60 over 9 reduced? Going once, going 3 times, Kabarak. What's that? Yeah, divide them both by 3, you get 20 over 3. The length of this side is 20 over 3, or 6 2/3 if you're keeping score at home. Wasn't that fun? Who would rather do math than any other subject in the entire world? Don't lie to me. Another blank piece of paper, please. This one will be quick. This will be